Hey there, everybody. I want to work out a difficult problem for you for 14.2. This is integrating over multiple integrals with unusual boundary conditions or difficult non-rectangular boundary conditions. So we're going to do the function x squared dA. Our boundaries will be y equals x, y equals 2x, xy equals 1, and we're going to have x is greater than 0. So I drew a picture here. We got y equals x along this line, y equals 2x along this line, and xy equals 1 along this line. And then I was finding the boundary points here. When we do A, we set y equals 2x and y equals 1 over x equal to each other. And you can see we get x squared equals 1/2, so x equals root 2 over 2. And if we plug root 2 over 2 into 2x, we get y equals root 2. So that's that point. When we plug in or match up y equals x and y equals 1 over x for this point here at B, we get x squared equals 1. So x equals 1 and thus y equals 1 because y equals x. So there's two ways to set this up. One of them is going along y first. So if we go along y, we got to break it up into two regions. To the left of this line and to the right of this line. So to the left of this line, the y portion is from x to 2x, as we see here. And we're going from 0 to root 2 over 2, the x component. And then for the right half, we're going from x to 1 over x, as we see on our limits of integration here. And from here, we're going from root 2 over 2 to 1. The function was x squared. We're doing dy dx. The other way to integrate is doing dx first, as I was doing in class or attempting to before I mangled the shit out of it. Let's just take a look at this. If we go from left to right, we're doing below this line and above this line. So below this line, going along dx, we've got, this is the y equals 2x or x equals 1/2 y line. So we're going from 1/2 y up to x equals y. We can see that here. And the y component from there is 0 to 1. 0 to 1. And then above that line, we're again doing still 1/2 to y, but now we're going up to 1 over y. So that's our limits there. And now we're going from above that line is y equals 1 up to y equals root 2. So again, we have our x squared dx dy. I've solved this both ways to show that we get the same thing. I did the way we've got in front of us first. So it was probably the messier version. The other one was a better choice. So we integrate x squared. We get 1/3 x cubed for both of them. Our limits of integration are listed here and here. When we work that out, we get this. So y cubed minus 1/8 y cubed. I left the 1/3 factored out. This is just 7/8 y cubed. And here we've got 1 over y cubed minus 1 over 8 y cubed. I just wrote this up here real quick because it's easier for me to see when I'm integrating what I'm getting. When I don't do it, I make mistakes. So I used the 7/8 y cubed here. When I integrated up the power, divide by the power, we got 7/32 y to the 4th from 1 to 0. I factored the 1/3 for all of them outside because I wanted to add it last. Didn't need to make the fractions more difficult before that. And for the second integral, we've got up the power is to -2, divide by the power is -1/2. So -1 over 2y squared. And then y to the 4th and the 4 on bottom minus 1/32 y to the 4th. And again, we've got a root 2 to 1. So when we evaluate that, I got the 1/3 outside. I got 7/32. When I stick in root 2 on bottom squared is just 2. So 2 times 2 is 4. And when I take root 2 to the 4th power, it's 4. So 4 over 32 is 1/8. And then I did the 1 value, which is 1/2 and negative 1/32. What I did is I didn't combine any of these. I just got a common denominator for all of them. So 30-second power, or not 30-second power, it's 30 seconds. That sounds funny. It sounds like time. 1/32 is the denominator, or denominator is 32. When we add those all up, we get 12/32 on the inside times 1/3. I reduced the 12 and the 3 first to get 4/32, and then that's 1/8. If we look at doing it the other way, we integrate dy, there's no y, so it's just y. We plug it the limits of integration. We've got x squared times 2x is 2x cubed. X squared times x is negative x cubed because it's a minus. On the other one, x squared times 1/x is x, and then x squared times x is x cubed. So there's our function. I combine these real quick. When we integrate that, we get 1/4 x to the 4th from 0 to √2/2. And then we get 1/2 x squared minus 1/4 x to the 4th from √2/2 to 1. So I plugged all that stuff in. We get 1/4 times x. When we take √2/2 to the 4th power, it's 4/16. And that shows up over here as well. So I got 1/4 times that minus 1/4 times 0, which I didn't list. This part is plugging in the 1/2 minus 1/4. And this part is plugging in the √2/2. √2/2 squared is 2/4. And squared again is 4/16. So this 1/2 minus 1/4 is just 1/4. These clean up to 1/16. 1/2 times 2/4, or 1/2 is 1/4. And this cleans up, cancel out the 4s is 1/16. So, and there's a minus sign there. So I just showed a little bit extra work there. This is brought over here by changing the signs of these, minus 1/4 and plus 1/16. These two clearly cancel out. I got 1/16 plus 1/16, which is 2/16, which is 1/8. And that's what we got on the other one. So we got 1/8 both ways. I'm feeling confident I did it right this time. Peace.